Okay, we're on lesson 7 of unit 3. We're looking at transformations of functions given a graph. And our learning goals for today include the ability to be able to graph any function with a variety of transformations, as well as to determine the transformations given any function, and vice versa. And lastly, to graph any graph of f of x given any set of transformations. These learning goals are identical to yesterday. The only difference today is that we are going to be looking at functions whose equation we do not know. All we know is their graph. Let's get started. So we begin example 1 with a function whose graph is shown right here. Obviously, we've never seen an equation for such a thing. I mean, it looks like a combination of a linear function, some kind of quadratic, and a horizontal function. So it's a whole bunch of things, which at this level, we do not know how to put into equation form. Okay, you'll learn that next year in grade 12 advanced functions. So the function is given by this equation. Now, off the bat, this is not in the form that we want it to be in. In other words, the transformations are not explicit. So let's do that first. Let's rewrite it. I'm going to factor out a negative 1, x minus 1, rewrite it in that form. So now we have our a, our b value, our h, and our k explicitly expressed. And I've written all the transformations for you just to save some time. So we have a reflection, a vertical stretch, another reflection in the y-axis, and both a horizontal and vertical shift. Let's begin now by recording the points where the function changes from left to right. So what do I mean by that? Well, let's take a look at our graph here. And in red, I'm going to circle the points I'm referring to. These points here are where the function changes. So let's begin by plotting our points here, listing them in our table of values. So the circled ones represent the areas, the points that I'm going to graph. So the first one is -7 and -3. So back 7 and down 3. My second circled point is -3 and 1. So back 3 and down 1. Then I get 1 and -1. So across 1, down 1. Oh, this is positive. And then I get 4 and 4 and 7 and 4. So 4 and 4 and 7 and 4. I'm just going to copy these values over to step 2 because we are going to use them again. -7, -3, -3 and 1, 1 and -1, 7 and 4. And now I'm going to apply the transformation. So beginning with the reciprocal of the b value, which in this case just happens to be -1, and my y value is multiplied by -2. So what happens to all the x's? Well, they just switch sign. And all the y's, the same thing, and they become twice as large. So 2 here, -8 and -8. Finally, I'm adding 1 to the x's and adding 2 to the y's. So the transformations, horizontal and vertical shifts. And I'm left with 8, 4, 0, -3, -6. And here are my y values. Okay, so now with our final table, we're going to plot these points, beginning with 8, 8, which is way up here. And then 4, 0, 0 and 4. -3 and -6. So back 3 down 6. And finally -6 and -6. There's our points. In addition to that, to graph it, we basically, wherever there were straight lines, we draw straight lines. Curved lines, we draw curved lines. And if we look at the graph above, it should give us some kind of guide as to how we're going to do this. Okay, so you notice the straight line over here. I'm going to have like a V shape. So let me just draw this here. Do better. This here. And then you'll notice the next part is a curved part. And how does that go? Well, it's kind of like a parabola as such. Make it a bit more explicit. Curve, curve, and then locks into straight. Then we have a straight line. There is our transformed function. As far as the domain goes, well, it's everything from 6 over here to 8, and our range is everything from -6 to 8 as well. So our domain and range are identical in this case. X is a real number from -6 all the way to 8. Similarly, y is a real number all the way from -6 to 8 as well. There's our first example of a function transformed, and we only know the graph. Okay, for our second example, we're looking at a new function. Here's the graph of the function. It's defined by h, and the transformations that are applied to it are shown right here. So if we look at it, obviously it's clear that we cannot write this, we cannot identify the transformations off the bat, so we have to rewrite it in such a way that we can see the transformations explicitly. Now notice I'm changing the 0.5 to 1/2. The 1 divided by 0.5 becomes 2. Then I get a +5 here. So just like before, we're going to start off by identifying the points that we are going to use as kind of our guidelines for transforming this function. So what I have circled in red is the points I'm going to list. So my first one is -3 and 4. So back 3 and up 4. My second point is -1 and 2. And then I have 2 and 2, 4 and 6, and 5 and 2. I'm just going to take those values and copy them down here. -3, -1, 2, 4, 5, 4, 2, 2, 6, and 2. Let's begin with the transformations that we are going to apply. So the first one I see is for the x value, we are multiplying it by the reciprocal of 1/2, which in this case is going to be times 2. The y values will be multiplied by -1. So what do we get here? -6, -2, 4, 8, and 10. And for the y values, it's just everything pretty much becoming negative. Now for our horizontal shift, well, the x value we subtract 2, and the y values, we add 5. Okay, let me just take a peek at the original. Yep. So what does that mean? Based on our previous table of values, we're going to get now -8, -4, 2, 6, and 8. The y values will become 1, 3, 3, -1, and 3 again. So those are our points. We can now go to our Cartesian plane and graph them. So we have -8 and 1. So that means I'm going back 8, down 1 over here. -4 and 3, so back 4, and I go up 3. I then have 2 and 3. Right here. 6 and -1. Right here. 8 and 3. 8 and 3 brings me here. So using the previous graph kind of as a benchmark where we want what we're doing here. So we do have a reflection in the x-axis, so basically everything's going to be upside down, which means that over here I'm going to get the v upside down. Oops, can do a better job there. And what else? Next I have the straight line. So from here to here, I have a straight line. And then finally I have my curved portion, which will look something like this. Okay, it doesn't have to be exact, just a rough idea. And that looks good. So my domain, well, everything from -8 to 8. All real numbers. -8 to 8. And my range is everything from -1 to 3. -1, not x, it should be y. Same thing here. And there you have it. There's our second and final example. I would suggest you try a few exercises to familiarize yourself with these types of questions. They will be on a future test.